Hi guys, in this video we are going to start our discussion on chapter 19 where we will look at creating confidence intervals. So to get us thinking in the right direction, we're going to look at the proportion of our class that watched the Super Bowl. Now I'm just going to use some old data that I had from last year. In one of my classes of 30 students, I had 21 of them that watched the Super Bowl. So I would write that as 21 out of 30. Which, when I change this into a decimal, gives me 0.7. So about 70% of my students watched the Super Bowl. From here, I could find Q hat, which would be the proportion of my students that did not watch the Super Bowl. That's 1 minus 0.7, which gives me 0.3. Okay, from here we can find the standard deviation for our P hat. We've seen this before. We would take the big old square root and we would usually start with P here, the true proportion. Now, I don't have the true proportion, but I do have P hat, which should be a pretty good representation of what's going on in the population. So I'm going to use P hat instead, and I'll use Q hat as well. So I'm doing P hat times Q hat there. And I'll divide by my sample size, which was 30 students. Okay, so we'll go ahead and type this in. And I got 0.0837. Okay, now we just found out some kind of key pieces of information from our sample. So what do you think we can say about our population, or P? Do you think that P should be 0.7 exactly? I mean, maybe not exactly 0.7, but I do think it should be pretty close. And to figure out just how close it should be, I can use this standard deviation. Okay, so what we're doing here is we're kind of making or thinking about a normal model where the average, the best guess for that average I have is my P hat, so that's my 0.7. And I know that each of these standard deviations is moving by 0.0837. So I may not know exactly where that true population proportion is. I might not know exactly where P is located, but I can kind of get an idea of where it should be located based on this normal model. So what can we say about the population, or P? It should be close to P hat. Okay, but today we're going to focus on just how close are we expecting it to be. Okay, so what we're going to do here is create confidence intervals. Now what a confidence interval does is it makes a guess of where you think that p-value should be in relationship to your P hat. So I only asked 30 kids whether or not they watched the Super Bowl, but based on those 30 kids, I should have an idea of the true proportion of high school kids that watched the Super Bowl. Okay, here's our formula for 1 proportion z intervals. We're going to start with our best guess of the average, which in this case is our P hat. Now we want this to be an interval. I want to look both above and below that average, so we're going to add and subtract. And to find this distance here, what I'm going to do is take a z-score, and I'm going to multiply that z-score by the standard deviation, which was P hat times Q hat over n. I am using P hat and Q hat here instead of just P and Q because I don't know what P and Q are, so my best guess is that P hat. So what this is going to do is give us an interval looking at that P value, or that P hat that we started with in the middle. We're going to construct these intervals, so this will be my lower bound and my upper bound, telling us I think that my true P value is somewhere in between there. Okay, now this distance is going to change. Sometimes it'll be like way out here. Instead, that distance is all changed by your z-score. Okay, this distance that we're adding and subtracting, this z times our standard deviation, this is sometimes called the margin of error. Sometimes we abbreviate that as MO. Love that abbreviation because my cat's name is Momo. I named her after margin of error. No, I didn't, but her nickname is Momo, so I love talking about margin of error. Okay, now one big thing that's changing from confidence interval to confidence interval is that distance that we're going. So the z-score is changing quite often. So I want to talk on the bottom of this page here about finding that critical value, which is just a fancy way of saying finding the z-score. Okay, so to find the z-score, the critical value, if I'm making a confidence interval of whatever percent, the percentage that we look at is always the middle percentage on that standard normal curve. So what they're going to do is say, I want you to create a 95% confidence interval. What that means is that when I draw my normal curve, I'm looking for the middle 95% of my data. So this area here in the middle should be 95% of our data. Our job is to find what z-scores cut off the middle 95%. Okay, now to find those z-scores, we are going to use our calculator. We're going to use inverse norm, and this looks a little bit different on each of your calculators depending on how new or how old your calculator is. So my older calculator here, when I go to second vars and I go to inverse norm, it just asks me for the area, which means I have to find the area off to this left-hand side. My calculator can only do areas on the left. So if this right here, this total of this normal curve should be 100%, I already have 95 in the middle, which means I'm left with 5% left over in these two tails combined. So 5% divided by 2 gives me 2.5%. So my area then would be 0.025, and I can go down here to paste. If you have a newer calculator, one that graphs in color, you might be able to type in the area and then pick left, right, or center. So you can just type in the 0.95 and click center, and it should give you the same z-score as I'm going to get here. So I have a z-score on the lower end at negative 1.96. Because these normal models are symmetric, this z-score should be positive 1.96. Okay, go ahead and pause your video. I want you guys to try B and C. All we're doing here is changing the level of confidence. So on part B, you're now looking for 80% in the middle. Part C, you're looking for 44%. Once you're done, go ahead and play your video to check your work with mine. All right, here are my two answers. For 80%, you're left with 10% on that one tail. So when you type in your inverse norm, make sure you're typing in 0.1 for the left, or you can do 0.8 for the middle. Should get a negative 1.28 and then also positive 1.28. 44% confidence, only 44% in the middle, so I'm left with 28% on this one tail. So I'm using 0.28 as my left-hand area. I get a z-score of negative 0.58 and positive 0.58. Now, technically, you can do this every single time. They give you a confidence level. If you forget what that z-score is, draw out your normal model, quickly use that inverse norm to find your z-score. I will tell you that there are 3 common critical z-scores or critical values. So these are your most common that you'll see. We typically stick with 90%, 95%, and 99%. We want things to be pretty confident. We want to be sure of our answers. So you typically won't see anything less than 90%. Okay, if you see 90% confidence, your z-score is 1.64. And I'm just going to be using the positive one here. 95%, We just found in part A that was 1.96. And 99% confidence is all the way at 2.58. Now, I recommend that you memorize these. It does save yourself some time if you know these 3 common critical z-scores, so I would memorize these ones. But if you do forget, you can always build that normal model. Okay, let's go ahead and look at the next page where we will see an example of what an actual confidence interval looks like. Okay, so on this next page, we are going to use our class data to create a 99% confidence interval for the actual proportion of YHS students that watch the Super Bowl. Okay, so we're going to start with breaking down the formula. We should have our sample proportions and our sample size, which we already found that P was the 0.7, Q we had as 0.3, and we had asked 30 students. Okay, the critical value, or my z-score, for 99%, we said on that first page was 2.58. If you don't believe me, you can draw your normal model. You're looking for the middle 98% of your data. So 2% left over, which means just 1% left on this tail. So you could do inverse norm of 0.01. You should get 2.58. Right, sometimes you'll see this wording here where it says standard error instead of standard deviation. Technically, standard error is what it's called when we have just our p hat and we don't have our p. I like to just call it standard deviation every time. So we'll go ahead and find that standard error by plugging in. Oh, actually, we already found it. On that very first page, we had already plugged everything in. So when we did our 0.7, our 0.3, and our 30, that's where we got our 0.837. Okay, from here, we can combine everything to create that actual confidence interval. So what we're going to do is take our p hat, we're going to add and subtract our z-score times that standard deviation. So our p hat is 0.7. I'm adding and subtracting the z of 2.58 times my standard deviation of 0.837. Okay, I'm going to simplify here so I can see what that margin of error actually is. So I'm going to do the z-score times that standard deviation. So 0.2159. And then to actually build this interval, we're going to write this interval kind of like an ordered pair. I want the lower interval on the left, so I'm going to do 0.7 minus this 0.2159. That's going to give me my lower bound. And then I'll do the same thing, but adding to get the upper bound. Okay, so our conclusion here, we're going to talk about how to write this conclusion. It's very, very specific on their wording. But the first thing that we want to start with is talking about that confidence level. Now, we were using a 99% confidence interval, right? That 99% confidence. So we're going to start with saying, I'm 99% confident. Now, what we're looking at is an interval here, and technically this is percentages, so this is a 48.41% all the way up to 91.59%. And now my p hat was 0.7, just smack dab in the middle here. I know what my p hat is, but what I'm looking at is what we think the actual proportion of YHS students that watch the Super Bowl is. I don't know exactly what it is, but I'm pretty sure, I'm 99% confident that it's in between these two values. So we're going to say I'm 99% confident that the true proportion of YHS students that watched the Super Bowl is between 48.41% and 91.59%. Hey, I'm pretty sure that the true proportion of kids that watch the Super Bowl is somewhere between 48 and 92-ish. Now that's a pretty big range, and the reason why that's so big is because we were looking for 99% confidence. So 99 means we almost had this entire normal curve shaded, right? Everything in here was 99%. Now, if instead of 99, I wanted to look at a 90% confidence interval, I'm now going to be decreasing that shaded area. Now I'm only looking at this middle 90%. So things will change as that z-score changes. You'll notice though, the higher your confidence level, the wider that interval. Okay, wording is super, super, super important. It's everything here. Okay, so I want to look through this list of statements that you would like to be able to say about the confidence interval, and we're going to talk about why each of them is incorrect. So part A, sometimes we get that p-hat and we like to say, my p-hat was 0.7, so 70%. So I want to just say 70% of all students watched the Super Bowl. Okay, that is not true because it is way too definitive. I don't know for sure that it's 70%. That's what happened with my class of 30, but it might be different for the entire school. It's way too definitive. Okay, part B says it's probably true that 70% of all YHS students watched the Super Bowl. So a little less definitive here, okay, but probably true. Like, what do you mean it's probably true? Can you imagine if I said it's probably true that you'll pass this class? Probably is very vague. Okay, so we don't want to say probably, and it's probably not true that it's exactly 70%. We want to be giving that interval. So C says we don't know exactly what proportion of YHS students watch the Super Bowl, but we know that it is between, we got 48 and roughly 92. So I agree we don't know exactly what proportion of YHS students watch the Super Bowl. That's true. But this one is saying we know that it is between here and here. We know means we're 100% certain. And we are not 100% certain of anything, so this one is too definitive. We know we don't know anything. Hi, D, we don't know exactly what the proportion of YHS students watch the Super Bowl, but the interval from 48% to 92% probably contains the true proportion. I agree, it probably does, but what do you mean by probably? How sure are you that it contains that true proportion? Okay, at the bottom of this page here, I gave you a template. You can use this template for every single confidence interval that you make if you're looking at one proportion. So we are blank percent confident, always plug in your confidence there. We are 90% confident, 95% confident that the true proportion of, here's where you're going to insert kind of whatever proportions you're looking at in context. So make sure you're putting that in context. YHS students that watch the Super Bowl is somewhere between what percent and what percent. If you use this template every time, your wording will hit every piece of the criteria that they look for. Okay, on the next page, we'll look at a few more examples of these confidence intervals. Okay, number 2 says your local newspaper polls a random sample of 330 voters, finding 144 who say they will vote yes on the upcoming school budget. We want to create and interpret a 95% confidence interval for the actual sentiment of all voters. So this is our goal here, to create the actual interval and then interpret it. By interpreting, they just mean write that little sentence, I'm confident that blah, blah, blah. So I'm going to start again with finding the variables that I have. So it looks like we surveyed 330 voters, so that's my N. P hat is 144 out of 330. So 0.4364. Q hat I can find by doing 1 minus that amount. So 0.5636. And notice that I do not have a p-value or a q-value. They didn't tell me what we think all voters believe. That's what we're trying to determine here. Now, we haven't talked about this in that last one, but because we are using a normal model and we're trying to use a z-score, we do need to check conditions. Okay, what's nice is we're still working with proportions, so my conditions are the same as we've been working with proportions for our sampling distributions. So the first thing I need is that random condition. This says that there was a random sample, so we know that that condition is met. Next, I'm checking my 10% condition. Do we think that 330 voters is less than 10% of all voters on the school budget? I'm assuming that this is a large school district, so I think that 330 voters will be less than 10% of all voters. Okay, the third condition, because we are dealing with proportions, we're going to make sure we have at least 10 successes and 10 failures. So what we'll do here is take our n value. Now we used to multiply by p, but I don't know what p is, so instead I'm going to use my p hat. Okay, that should give me 144. That was kind of given to me. Those are the people that are voting yes. So 330 times my q is roughly 186 people. So definitely greater than 10 here. So I believe all three of my conditions are met. Okay, from here we can go ahead and start building that confidence interval. Remember, we're taking our p hat, adding and subtracting our z-score times the standard deviation. Okay, the only thing I don't have right now is that z-score. For 95% confidence, my z-score is 1.96. Okay, again, you can get that back on page 17, or you can make a quick little normal model and use inverse norm. Okay, I like to start with plugging everything in, so I'm going to have my 0.4364 plus or minus 1.96 times the square root. 4364 times 0.5636 all divided by 330. Okay, now you can just type this all into your calculator at once. I personally like to see what the margin of error is, so I like to look at just this piece here to see how far off we are. So I like to type just that right-hand side in. Okay, and we get 0.0535. So that's nice. That's showing me that my estimate here is about 5% off. Okay, we'll go ahead and add and subtract on both sides there to actually get my interval. So I'm going to do my 0.4364. I'm going to do the lower bound first. 3829. Upper bound. 4899. Okay, the last part here is interpreting. So my interpretation will say I'm 95% confident that the true proportion of, I'm going to stop for a minute and put this in context. We were looking for the actual sentiment of all voters. Particularly, we're looking at those that are going to vote yes. So I'm 95% confident that the true proportion of voters who will vote yes is between 38.29% and 48.99%. Okay, so we are pretty sure when they count up all of these votes here that we're going to get yes votes somewhere between 38% and 49%. So basically what we found here is we're pretty sure, we're 95% confident that this new school budget is not going to pass because more than 50% of people are not going to vote yes. You can go ahead and pause your video, go ahead and try example 3. It's very, very similar here, making a confidence interval. Make sure you're paying attention to the percent confidence that it gives you. Once you've tried it on your own, you can go ahead and play your video. I'll show you my work and walk through the answer. All right, answers for number 3. Make sure you start with checking those conditions. This one wasn't very clear whether or not it was random. All it says is that there was an experiment. So I just said that hopefully the experiment randomly assigns their subjects to the treatments. 53 subjects should be less than 10% of all subjects, and taking my n times my p hat and n times q hat does give me at least 10 expected successes and failures. Okay, I started with plugging all of my values into my z-score formula. Okay, now we're looking for 90% confidence, so using a z-score of 1.64. Give us a margin of error just 0.1. So I have between 17 and 37%. Okay, this means that I am 90% confident that the true proportion of subjects that will have improvements is somewhere between 17% and 37%. I can't stress this enough. Make sure that you really are focusing on how you word that interpretation. If you are working on this practice today and you're unsure, feel free to send me an email. I can look over your wording and make sure that you're doing things okay. Okay, the only other thing that I want to point out is what happens if you come across an example like you'll see on number 4 on the next page where they do not give you a p-hat. They don't give you a proportion. So number 4 says in a poll taken in March of 2007, the Gallup poll asked 1,006 national adults whether they were baseball fans. We want to create and interpret a 99% confidence interval for the percent of national adults who are baseball fans. They don't tell me what they found with those adults. So when we're trying to prove here whether or not they are baseball fans, they don't give you a percentage, then just use 0.5. Okay, if no p-hat is given, you want to assume that things are 50-50. That does not happen very often, but it does happen here and there. Go ahead and try 4 and 5 on your own, and then you can check your answers using the answer key found on Canvas.